So today's lesson is all about common factors. Now, common factors is one of the most important things in mathematics when dealing with parabolas and other ideas. Now, when we talk about a prime factor is basically a bunch of primes that multiply to give a number. And it's a fact that every number that is in existence, every whole number in existence, has prime factors that make it up. So for this one here, 12, its factors are 4 and 3, but 4 can be broken down into two prime numbers, 2 and 2.
Yes, sir.
And the number 8 can be written into 4 times 2, which can also be broken down into 2 times 2. When we're looking for the greatest common factor, we're looking for the numbers that match in both. In this case, we have 2 times 2. So, basically, the 2's match in this case. Therefore, when you're doing these calculations, you could say the GCF of 12 and 8 is just 2 times 2, which gives us 4. And now, in order to write that properly as our solution, you would say the GCF bracket of 12, 8 equals 4. So basically, the greatest common factor is just the biggest number that divides both or more of our sets. The next set, we have 6, which breaks down to 3 and 2. Can't break that down anymore. But 8 can be broken down into 4 and 2. Just like before, but the 4, just like before, could be broken down into 2 and 2. And 24 has the same properties. We can break that down into, well, I usually start with 2's, and then I go to 3's. So now I got 2, which breaks down into 12, and then 12 can break down into 2, and then 6, and then the 6 can be broken down into 2 and then 3. And then all we have to do is look for the matching values. In this case, the only matching value for all three numbers is going to be, you guessed it, 2. So now all we have to say is the GCF of these three, 6, 8, and 24 is 2. Now, let's go to our next set of problems. So now let's look at powers. When we're dealing with powers, we can break them down easily. We can basically just look for the lowest matching power. So the lowest matching power that is contained in both of these numbers is going to be 5 cubed. Now, I'll just go through the work here so you see where it's going through. So 5 cubed is the same as, well, 5 cubed, but then we also have 5 to the 6, which also breaks down into 5 cubed times 5 cubed. So we use the lowest power that's common to both, and in this case, the GCF of 5 cubed and 5 to the 6th is 5, 3. Now, all you got to remember is you're just using lowest common power between both numbers as a GCF if you have the same base raised to different exponents. That's all you got to do. Okay? Now for the next one, we have x to the 4 and x to the 7. In this case, the GCF of x to the 4 and x to the 7, the minimum power is going to be, well, x to the 4 by using our rule from before. For the next problem here, we have 3 different parts. In this case, we have 3 and then y squared, and then we have 3 and 3 for 9. Now, the only matching term between all of them is 3. So therefore, the GCF of our values, 3y squared and 9, is just going to equal, you guessed it, 3. Now, for the next problem, we have 21c squared d6 and 28c cubed d to the 5. So the first thing we got to do is we're going to eventually split these up. The 21 splits into 7 and 3, and the c and the d squared and the d fourth are just split again. Now, if you think about it, we're going to take the 28 c cubed and d to the 5, and what we're going to do is we're going to split that up and break that down as much as we can. So 28, it breaks down into 2 and 2 times 7. But then c cubed and d to the 5 are also broken down. And all we have to do is take the lowest common power between the two of these, and what we find is that I forgot to go and eventually break down 21. So let's make sure we do that after we finish writing this GCF. So the GCF is going to be based on, well, 21 is going to be broken down into 7 and 3. So for the coefficients, the lowest, the greatest common factor is going to be 7 between the two of them, the 21 and the 28. Then we're going to also take the lowest power between the two of each variable. So we got c squared and d to the 4th. So that means our GCF for this problem is going to be 7c squared d to the 4th. So just remember, anytime you use variables as part of your GCF, you need to make sure that you use the lowest power between both of them for each variable. And the big idea, all you really understand is this: when you take a look at our new concept, we're going to be using the GCF to help us with factoring, and factoring is just the opposite of expanding. When we hear the term factor using GCF, all we're looking for is a matching pattern. When we look at this first problem here, you'll notice that both multiplication complexes have z plus 1. So all you do is you're just going to pull those out, and then in the second bracket, all you're going to do is put the coefficients that were in front of it in the other bracket. In this case, we get 2x plus 5y for our second bracket. Just remember, the GCF is literally z plus 1, and that's how we ended up pulling these out. Taking a look at the next problem, you just need to remember that all we're going to do is factor out, i.e. pull out the common number or bracket within the complex of multiplicative parts. Okay? And just remember that the last part of everything gets put, the last part is whatever's left over goes into the second bracket. So in this case, our GCF is going to be x minus 3. We pull that out, and then we're left with 6 minus 5y. And in that case, the GCF was just x minus 3. How about the next one? Let's do it again. So the GCF in our case is now going to be y minus 1. And now, what we're going to do, in order to make the second bracket of 1 minus y turn into y minus 1, is literally this. we're going to go and rewrite our problem to be 3x. Now notice I'm going to put y minus 1 in red. And then in order to change the second bracket of 1 minus y into y minus 1, we literally have to pull out a minus. We actually have to pull out negative 1. So plus minus negative 1 gives us negative 1. So if you think about it, you got a minus sitting out front, and then you end up with y minus 1. Now, this part here is plus and minus 1. So all of this now becomes 3x, y minus 1, minus bracket y minus 1, because plus minus 1 becomes minus 1. So now our common factor is literally going to be this part in red, this part, and this part. And that GCF is what we're going to pull out. So we're going to get, well, y minus 1. And now what's left in the last part of the bracket is going to be 3x. And then basically this whole second part here that's in blue for y here is going to be divided by itself, which means we end up with minus 1 in the second bracket. And we're done. Now let's move on to the next set of questions. We're going to be factoring by grouping. We're going to do the first two and we're going to skip the third problem. It says factor fully if possible. Now, in order to factor fully, we have to create a situation where we literally have two separate brackets. In this case, I'm going to take the first half of our equation, I'm going to underline that in blue, and the second half of my equation, I'm going to underline in red. Now notice, I also include the plus 2x, the plus as well. So, in order to do this, we literally start by putting what the first half of our bracket, of our equation in brackets. So we got ax plus ay. And then we're going to have a plus the second half of our bracket. Now you'll notice how I put plus 2x plus 2y. Now that I've done that, what we're going to do is we look in the first bracket, the blue half of our brackets, and we look for some greatest common factor. The greatest common factor in this case is going to be a. So all you're left with is now x plus y. And we still have our plus. And now we have to think about our second bracket. What's common to both of the plus 2xy and the 2xy? Well, it's literally the number 2. So I'll pull that out. So we're left with x plus y in the second bracket. And so now the common factor for both of these is literally x plus y for both complexes, and then we just throw the rest of the work in our brackets, and that's literally the a and the 2, the plus 2. So we end up with a plus 2 in our second bracket. And we're done grouping by factoring. Now, pause the video and take a look at part 2 of this problem. We will not do question number 3 on our sheet. Pause the video and do part D, part D2 on your own. And then check your answer. See if you got it. Now let's work through part 2. Now, what we have here is 2 halves of an equation. So I'm going to split those two, and the first half is this, and then the second half is this. I'll write the first half in red. So when we split the variables, we must basically put half of our equation in the first bracket, and then the other half in the second bracket, and put a plus in between. So let's do that. So for the first bracket, we're going to have 9x squared plus 15x. Then I'm going to put a plus in between us. Then what I want you to do for the second half is you're just going to put 3x plus 5. Now that I've got that, you look at the first bracket and you look for the greatest common factor. So for the coefficients of 9 and 15, the greatest common factor is going to be 3. And now we also have to look at the x terms in our bracket. You'll notice I have x squared and x, so we're going to take out the lowest power, and that's just x. So now we're left within our bracket, well, 3x, because now 3x times 3x gives us our original 9x squared in our first bracket. And then 15x divided by 3x is literally just going to be plus 5. Now, what we can pull out from the last bracket is we're just trying to make sure that the last bracket's the same. So you know what? I'm going to imagine I pulled out a 1 from that bracket. And then what's left over in my bracket is just 3x plus 5. And all we have to do now, let's go back up here. There should be a plus in here. And then when we pull out the plus 1, we're left with these 2 brackets. So the common factor that we have now is going to be 3x plus 5. We're going to put that out front. And then we put in the second bracket the results of what's left over. So we have 3x plus 1. And we're done. So now your homework is going to be these questions at the bottom of the page. And you'll notice it says here, basically take a look at the key concepts on page 233. And all you have to do is just read it. If you feel like you could use it, add it to your notes. And on 324, there's also some more big ideas for the chapter that we just did. And what I want you to do is do all of these questions, page 234 to 235, number 6 to 9, 11, and do the extra challenges.